performs some commands, or it uses the web search to find something on the internet or read documentation and so on. So if we do this, essentially in terms of the difference, when we do a single LM call, it is a stateless thing. So LM is like this big function where we can send a prompt and it will spit out an answer. But agents have state, and when we work with LMs directly, it's a bit harder because we have to manage everything. We have to manage the conversation history, we have to manage how we present that, we have to manage essentially everything. We orchestrate how this whole thing works. But with agents work in a loop. They maintain that loop. We will see in ADK we don't have to care about the implementation actually of that. It can do tool calls, it can maintain its context, so you don't need to worry about how like the conversation goes because it's already handled. And the agent decides when to stop, what to do next. It can be super autonomous, it can be partly autonomous, it can be essentially a workflow where your LM just step in sometimes to perform some tasks. So it can be wildly different depending on what task we're trying to accomplish, right? Now, so what is an agent in terms of code? Like if we think about code itself, what do you mean that this code is an LM agent? Well, it's essentially just a loop. It's just an endless loop where the LM can perceive something. This means we make a call to LM and ask a question or give it a task. And it can make a decision what to do. It can be to just be an answer to that question. It can be just like a function call. It can be an error, for example. Then it can act. Essentially, it can decide which functions need to be invoked. Then it can loop again. It can update and check, like, see if the goal that we gave to it has been accomplished. If not, it can repeat this process. Okay. Now, if we replace the decide part of an LM call, that becomes just an AI agent. Doesn't matter what LM is used, doesn't matter how our code looks like. If we have a loop from out of which we can only break by an LM, then we have essentially an AI agent. Okay. Now the good part is we don't have to write any loops, we don't have to write any like this sort of imperative code. ADK creates already that loop for us. What we have to do, we just need to write instructions and define tools for it. Okay. Now, if we didn't have ADK, we would write something like this. We would write something like while true, we would make a call to some LM. And then we'll check if the LM has responded with any tool calls. Now, what are tools? You probably have heard about this concept that LMs can access tools. Now, a tool, from the perspective of LM, is just a JSON schema that defines a function that can be used for some purpose. Okay? It doesn't actually work the tool, it doesn't actually call the function, it doesn't have this capability. LM can just generate text. Okay? Instead, the LM can say, oh, okay, you want me to do this task, but I realize that in order to do this task, I need you to, for example, go to the database and find this or that and tell me what that value is. Or I want you to run this bash command and maybe delete a file or whatever to accomplish this task. So when we call an LM, it can respond with a text, or it can respond with a function call. It can also like respond with both. But if it responds with a tool call, this means that we're not done yet. Because the LM says, okay, to accomplish this task, I need this to work to have some result. So then we will just execute the tool and tell the LM the results. So we'll say, for example, if I say, oh, I want to add a new to-do item in my to-do list, it will say, okay, you gave me this function, this to-do function, it's called add to-do. Now I know, you have to call this function with this argument. And then you call it and tell it, oh, you know, the database gave me an error when I called this function. And the LM can be like, okay, let's retry. And the next time it works, the LM can say, okay, nice, I've successfully added your to-do item to the database, and after that we'll just show the final text response. Now we don't have tool calls because the LM is like, yeah, I'm done. We accomplished what we wanted, and then we break out. So, agent is a super fancy word for a loop. Now, how does it work in terms of ADK? So that function that we just called in the abstract call LLM is a class in ADK called LM agent, so you can just define the agent. And we can give it a model, I mean a model string, like we can say, for example, use Gemini 2.5 Pro or a different model. This has tool call is internally handled by ADK, so when we send a message, ADK will figure out if there's a tool call. It will perform the tool call, we don't need to write any additional code, and we'll just send it back to LLM as much as until the LLM decides that, okay, we have accomplished the task. ADK tool, instead of doing that, we just use this function tool class to define the tool. I will show you the code examples next, and we just give it to the LM agent so the LM knows that, oh, okay, these are the tools that I can use. And there is session state. This is also handled, but usually in real life scenarios we provide a different implementation of session state. We might want to store sessions in a database, in MongoDB, or I don't know, maybe even VectorDB if we want to be able to search this session state. But in general, it stores everything in memory. During development, that's kind of comfortable. We don't need a database when we just are developing an application. Okay. And the break condition is also handled by ADK, so we just give agent the instruction. We're saying, okay, you are the agent that handles this or that, and based on that, the LM will figure out when it is done or not. Okay. And we can also kind of give it an output schema if we want some JSON output, some structured format. So, okay, now how do we implement an LM agent? So we just use Google ADK. We import an LM agent class from there, and we can define an LM agent. We give the agent a name, we define the model that we want to use, like in this example, Gemini 2.5 Flash. By the way, if you think about, well, this is Google's framework, so it kind of supports Gemini model out of the box. So you can just say Gemini 2.5 Flash and it will work. You can also use other models. You can use other models. There is no restriction on that. But Google ADK is available in TypeScript, Python, Go, and Java, this framework. But in TypeScript, it's a bit weaker. For example, in Python, you can use the light LLM class to just define a separate thing. So instead of giving a string here, you would say a light LLM class and pass another model like, I don't know, OpenAI, GPT-4 or whatever. In TypeScript, you would have to implement an adapter class if you want to use a model from a separate provider. For example, maybe you might have something like OpenRouter that allows you, we have that set up at work where we do agents. But for the purposes of this workshop, you just use the Gemini models. After all, this is GDG meetup, so let's just use Gemini models. I know, right?
Is it fast enough for you?
Oh, I think being fast is not the problem of the Gemini models.
I couldn't agree less. Just the last evening, I had, but not 2.5, 3.0.
Pro or Flash? But Pro or Flash? Flash is super fast. Pro is slow.
No, 3.9, 3.0 Flash, yes.
It was slow?
It was terribly slow.
Interesting. Well, they have been deploying 3.1 now. 3.1 is now available in the Gemini app, so maybe they messed up something in their infrastructure. Every time they deploy something new, it gets slow. But usually Gemini 3 was super fast for me. Flash, not Pro. Pro, obviously, the thinking mode is does reasoning chain of thought, so it will take longer. It highly depends on the task that you want to do. If you want an agent that like solves math problems, you probably better use a reasoning model like Gemini 3 Pro or I don't know, Opus from Code. So yeah, you give a description here. Now this description doesn't do anything for the LLM because the LLM usually doesn't see this description. But because in ADK you can combine multiple agents, so for example, one agent can become a sub-agent of another one. So another agent at some point may decide, okay, this other agent needs to work, and they can transfer, so they can use this description. But for this LLM agent, this description is just like documentation, just saying this agent is used to do that. So in this case, this is an agent that reviews your project setup and dependencies. I don't know. Now this instruction is what actually the LM sees when we send a message to this LM agent. What will happen is that the agent will see this instruction, and on top of that the user's message. So this is like a system prompt, and whatever the user sends, the agent will start handling it. And we can pass an array of tools. We'll show in the next slide what a tool is, how we define it in ADK language. We can pass as many tools as we want, although it would be better to have them be specialized, because if you pass like 100 tools, all of these tools are also being sent to the LM. So that's additional stuff in the context window of that model. So you have to be a bit careful. If you have like 700 tools here, expect your model to perform a bit worse. Doesn't matter if it's like Claude or Gemini or whatever. We usually try to keep context slim, not too slim, but also not too like polluted.
Can you make a dedicated agent for grouping the tools for that? So, for example, one agent for file management?
Yes, usually that's what happens. Usually you have sub-agent. You prefer not to have too many tools. Instead you have like an agent. If you know you have another intelligent task, for example, well, first of all, you can also turn an agent into a tool. You can use an agent as a tool for another agent. So sub-agent and agent tool is a bit different. When it's a sub-agent, what happens is that the parent agent transfers control to the sub-agent, and the sub-agent works and then it transfers back. But when it's a tool, it can work in parallel to other tools, so it can do several things at once. Yes, usually it's a good practice. If I know that, for example, I have an application, well, I am building a RAG system, like retrieval augmented system at work. It's a graph RAG, so it uses a graph database. It performs queries to that database. Now, the agent that actually does the querying has a tool, obviously, to call that graph database, but it's not the root agent. So we have a root agent that decides if you actually need to do the calls at all. It defines a strategy, and if needed, it calls the sub-agent that can actually make the database call. So now the sub-agent has only this one tool, it can only query the database. Okay. So yeah, in short, it would be good to split into multiple agents, and each agent has just a small amount of tools rather than have just one LM agent that handles everything. Although in today's project, because we're like in the beginning phase of this, we'll mostly be working with one agent that has tools, so we'll be defining tools to solve some problems on the project that I've created for you guys. Now about the tools, if you are working with Task, are you familiar with Zod? So Zod is a way of providing TypeScript types at runtime. Okay, it's widely used in ADK for like definition of schemas, like oh, this LM needs to output this sort of thing, or this other tool needs to receive this sort of thing. So in function tool, we give the function a name, we give a description. Now this description is super important, because the LM sees this description. The LM needs to understand what the tool does to decide if it needs to call it or not. So in this case, like we have a function tool that can go into your project, check your package JSON, and return some versions to the LM, so it can be like, yeah, okay, I know in this specific project which like dependency versions I've used. We give it the parameters. We define that it needs the contents of the package JSON. Okay. And then we will parse it. We'll find the versions of like dependency of Angular core, for example, and we'll return the Angular version. We'll say, okay, this is the Angular version. So this is a tool that the LM can use to check. Yeah.
But you could provide also the access to the file system just.
You could do anything.
Yeah.
It highly depends. With LMs, it's a bit hard because there is no right or wrong. With LMs, you can do anything. You can create a tool, like for example, how Claude Code works, for example. It just has, Opus is very good with bash commands. It has a tool that allows it to like perform bash commands, and it just goes through it, it tries a bunch of things, it sees what sticks, it like builds an idea of what's going on in a workspace. usually, when you give the agent a super powerful tool, like if you give the bash script and just say, okay, invoke it wherever you want. If it's a coding agent, makes sense. Well, it needs to read files, update files, delete files. If you're building an agent to handle like your, I don't know, your ideas that you store in MDEV files and you give it like this super high level access, it's a safety issue. It's also an issue of like, we all know that LLMs sometimes are incorrect. So the more power you give to it, the more incorrect can it be. And you can do so much more harm if you give it too much power. Usually you try to define your tools. Also, it's easier to debug your stuff if you have more like granular dedicated tools, as opposed to like having one powerful tool and then you have to check. Like if you give it a bash command, it can just execute bash. Then you need to know bash quite well to understand if the commands it generated is good. If you don't know bash very well, then good luck debugging why it's slow, for example, why it does like 17 commands instead of 5, for example. So yeah. Now when you define a function tool, you just provide it to your LM agent, and depending on what the user asks in the future, it may or may not use this tool. Again, you can have multiple tools. You usually have multiple tools. And in this scenario, you can imagine that like if I open up this agent and say, oh, okay, I don't know, is this project like really up to date? You can call this get Angular version. See that you're stuck on Angular 12 and be like, yeah, bro, you know, Angular 21 is out. Why are you still using Angular 12, for example? So yeah, that's the whole idea. Of course, there's a bunch of other things that goes on. Just to quickly recap, most of those things will probably not touch today during the workshop itself, but a lot of useful things that you can do with LLM agents is you can provide callbacks. You can do before agent callbacks and after agent callbacks. What this means is that you can execute some code all the time before the LLM is called. And it is useful because in that code you can catch some scenarios and, for example, not call the LLM at all. Like, for example, you want to have specific command, like the slash command in Telegram bots, or I don't know, in Code also you have slash command, right? So when you type like slash model, the LLM doesn't work, it just shows you the models that you have. So in the before callback, you can, for example, catch commands like this and just don't execute the LLM. You can have after callbacks. In after callbacks are super useful because LLMs are dumb, all LLMs are dumb still. If you are building your agent, you need guardrails, you need to check that they actually kind of did what you wanted to do. You can have the same callbacks in tools. In tools, you also can be like, for example, you give it a tool to execute queries on the database. As a safety measure, you might have a regex there that checks that it doesn't generate like commands, sort of like, oh, drop database, I don't know, or something like that. You might have. Sadly, when you build AI agents, like 90% of the time, that's the stuff that you're building. You're not building super cool prompts or I don't know, fantastic workflows. Usually you're building these guardrails to make sure that it is consistent. Like one part of our testing is we have a data set of questions like this eval set, and one type of testing we do is like run the same thing 5 times. Make sure that it like at least 4 out of 5 times it does it the same way, right? And when you try to ensure it, a lot of times it's like the very example I gave in the graph rec, there's this graph database called Neo4j. I don't know if you're familiar with it or not. It has its own query language, Cypher. And we're using, by the way, only open source models there because there are some data sovereignty issues with that agent where it's used. And some of the open source models are very powerful, but they are a bit more wild than, for example, Claude. Like Claude opens models, and when I allow it to create like Cypher queries, it always creates these valid Cypher queries. Some open source models that we are using are way faster, but they make mistakes. But they also make mistakes that can kind of be fixed programmatically. So we came up with, we is a strong word, like me and Claude Code came up with like this regex that allows to sometimes repair some of the queries. So yeah, it's not super fun, but it's also kind of interesting. Okay, even if the LM failed, we still can like nudge it a bit and it still works. So that's what you usually do when you work with agents. You can provide like structured outputs here. You can say, okay, the LM response, it needs to return like this sort of JSON. It doesn't need to return the free text or something. And you can provide like output key that will allow to take the specific output and then plug it into another agent. You can provide sub-agents and so on and so on. In the multi-agent context, now we usually don't want, as I already mentioned, we don't want one agent to do everything. We usually want to delegate, especially if we're doing some specialized things. We know different tasks may require different prompts. Also, it helps in terms of context. It's always very good if you are doing this big task, half of your context is already filled up. Now, one subtask you can just delegate to another agent and keep your previous context free. It's also easier to debug. Sub-agents can become tools via agent tools. As mentioned, this is a bit different, so you can mix sub-agents with other tools, and then the LM can just call several tools, and one of them is an agent. But the LM doesn't know, it doesn't need to know, it just says, oh, okay, there's this tool that can, I don't know, answer a question about United Kingdom's history. Okay, I don't care, they call that tool, and then the tool is actually an LM under the tool. Now this is how it kind of looks. So we always have a root agent when you open the project. That if you haven't cloned it yet, there is a link at the end of the presentation. You always have one root agent. It makes sense. There needs to be some agent that actually receives the messages like from users, and it's usually what we call the orchestrator. So it decides what needs to go on after it receives the message. And the orchestrator can call like different tools and sub-agents and then get the results back. So it's just a bigger loop, okay? It's a loop inside a loop. We don't know much about how it goes under the hood, and you will see that it's like the biggest reduction of code. If you had to implement this all like manually, I mean like without a framework, it would be super hard. And if you are familiar with things like LangChain or LangGraph, I don't like them, not because this is a Google tool and I'm doing free advertising for Google, but because initially I was working with LangChain and it was super verbose for me. Like it had classes for everything. I don't know, human message template, agent message template, blah blah. In ADK it's a bit shorter, not a bit, it's actually quite a bit shorter, and I think it also provides you with this nice web UI that you can run with a command, and then immediately in your browser you can send messages, upload files, everything, so you don't need to like code or vibe code anything to start debugging and testing your agent. This is how you can wrap your agent as a tool. You can just use this new agent tool class, and this is another, as you can see we have like two LM agents here. This LM agent has these tools, but it becomes a tool for this other agent, and depending on user's question, it might get invoked. So you can see it becomes this tree of dependencies, like this agent invoked this one, and this invoked the tool, and the tool did this and that. It's a big capability, so you also need to be kind of careful about what you're doing, as mentioned. Now how it works? It works a bit because it's a framework. It has a lot of wrappings around like how it should work. It doesn't work as a simple LM call. You are not handling also the streaming part and so on. ADK it emits events by default. So every time something happens in your workflow, like the user sent a message, okay, the LM responded with this, for example, or the LM responded with tool call, okay. Then the tool call performed. Now we're calling the LM back. Okay, the LM said let's transfer to this other agent. Now you see the other agent, and so on. When you run the web interface, you will see that. Now it streams these events as these big JSON objects. So you can see, like for example, the delta, and you can use the changing the text to update your UI, the text part of your UI. You can see tool calls, if it has any tool calls. For example, if you're building this big agent, you can show in your UI that like, oh, now it called the database tool. Oh, okay, I'm searching the database to find this and so on. You can get the tool results and be like, oh, okay, I finished looking up the tool call or looking at the database. And you can get the agent and say it's like the final response, we finished this one, and you can just show the text. Essentially, you are just, again, you're just checking for if there are any more tool calls or not. And because we are talking about Angular 2, how you could work in Angular with that, well, Angular is kind of very comfortable to use with stuff like this that has streaming in it. So we can use resources and observables to subscribe to the strings that ADK emits. You don't need to do much. Actually, when you spin up ADK as a server, it already gives you an endpoint. It's called run SSE, which you can call with the user's message, and then it will start streaming events to you. You can just read them via an observable or a resource. You can have like a computed signal that can incrementally update your text. Like if you're streaming tokens, you can just add new tokens in the end of it and show it as one message. You can also use the tool results to do, I don't know, some generative UI. For example, you did a database call. If you know that's a database call, you have some result. Maybe you want to generate a table, and it's very flexible because you as a developer never know what kind of table it will be, okay? The AI will like find something, give you something. So yeah, it's cool, but also a bit stupid. It's super hard to debug, like someone can come up with a bug and you have no idea how to reproduce it. But it can be super cool in some scenarios, like for example, generating reports. If you have this big database table and the user wants some specific visualization of it, instead of implementing an endpoint and then implementing a front-end service that has 1,000 parameters that you can send, you can just ask the LM to find whatever the user wants and return a schema dynamic one that you can render in the UI, and that's super cool. The user can just ask for whatever report they want from the database. And you can use like a signal store to also store the session state, maybe store it also like in local storage, have the synchronization, maybe rehydrate from there. So Angular is kind of in a good position to out of the box work with stuff like ADK and agents. And yeah, this is just a simple example of like how you can have a service that stores in it whatever you want from the agent stuff. Now this URL is bad. It should have been something like /something/run SSE, but you don't have to care much about it. In the actual project, it is implemented correctly. And you can use this text decoder. If you're not familiar, it's used for streaming. So now when you get a response body that is not like JSON, you can start reading using a decoder. So it means like streaming chunks. And then again, you have this other loop here. This is obviously different from the agent loop, but you can just update your signal chunks, for example, and then you can, this final response you can use in your component to display in the UI. Okay, now we have a repo, which I think David posted yesterday that you could have cloned it, but if you didn't, it's okay, because we planned for you to start cloning this repo today. Now, what you need to do, you need Node 24 plus. I'm not super sure about it. You need Angular CLI to run it, to run the front-end part. But you can only run the agent if you only want to interact with the agent. I will show you. If you want to be able to continue doing this after, you can generate your Gemini API key. Gemini AI Studio, you know about AI Studio, you can go on AI Studio and get a free API key. It's a bit limited, but for personal use, like for testing something, it's okay. If you don't want to do that, I'm going to generate one and I can give it to you, but after this session, I will disable it, okay? So this is the three things you need. Angular CLI maybe not super important. You can just use the agents UI. I will take out my computer and show you. You can use this URL to do git clone. There's a GitHub repo. And then actually there are two folders in this. One is called frontend, one is called backend. So you have to do npm install on both of them. And then you can do ng serve for the Angular frontend, npm run agent. This is for the agent server. If you don't want to do that, if you don't want to use the Angular frontend, if you want to see just the just the ADK web, I'm going to show you very soon. And you do npm run database to run the mock database. Also, there is a QR code. Yeah, you can actually. Ah, yeah, right. I have it in the presentation. So.
Shouldn't there be HTTP as before?
I think I tried it right this way, but yeah, you can add if it doesn't work without it.
It doesn't work.
Okay, you can, if you tried and it didn't work, add HTTPS :/ to it, sorry. Yeah, actually, if you don't want the Angular frontend, you can run npx ADK web agent / in the root directory of the backend folder, and it will give you a URL in terminal. Navigate to that URL. I'm going to show it, and it will show you the ADK dev UI. Okay, but if you want to also play around working with Angular, then also npm install the Angular frontend and run ng serve. Now I'm going to take out my computer so that I can show you the project.